In this video, we will learn about mixed strategy Nash equilibrium. Okay, so before we know what is meant by mixed strategy, we know that in pure strategy, there is no probability attached to the choice of strategy. Okay, so either the player plays a strategy or he does not play. There is no probability attached to the choice of strategy. Okay, but in case of a mixed strategy, let me write the definition. In case of mixed strategy, I will try to explain it with an example. You will get a very good idea how it is done. So, mixed strategy says it specifies that an actual move be chosen randomly from a set of pure strategies with some specific probabilities. So what does this mean? Whenever a player randomizes his strategies with probabilities associated with each strategy, we have a case of mixed strategy. Okay, so let me give you an example. You will learn it very easily with an example. Okay, so let's say we have two players. Okay, so we have player 1. Let me write P. Okay, I will write player 1. We have player 1. Okay, and obviously player 1 has two options, either to go up or go down. Okay, similarly we have player 2. Okay, he has also two options, either to go up or to go down. Okay, now in mixed strategy, what does the player do? They randomize their strategies. Okay, let us say player 1 plays up with probability p and down with probability 1 minus p. Okay, 1 minus p. Similarly, player 2 will play up with probability q, let us say, and down with probability 1 minus q. Why is this p plus 1 minus p? It will come out to be 1. Okay, and let us write the expected payoffs. Let us say we write 50, 80, 90, and 20. Okay, these are the payoffs for player 1. Okay, and similarly for player 2, we have payoffs like this. We have 50, we have 20, we have 10, and we have 80. Okay, this is our game. Okay, what does this says? When player P plays up and player 2 also plays up, then player 1 will get 50 as payoff. Okay, and player 2 will obviously get 50 as payoff. Okay, so this is payoff matrix. I hope you know it very easily. And similarly, what does this 20 specify? It specifies when player 1 plays down and player 2 plays down, the payoff that player 1 gets is 20 and the payoff that the player 2 gets is 80. Okay, so now let's see what happens. Let us see, suppose that player 1 mixes his strategies with probability p and 1 minus p, whatever I have told you earlier. Then let us say this player 1, okay, mixes her strategy. What are the strategies? To go up or down. Okay, with probabilities p he plays up, with probability 1 minus p he plays down. Okay, either he can choose strategy p and down with probabilities p and 1 minus p respectively. Okay, similarly what can player second do? Player second will also choose uh, the strategy u, okay, with probability q and D with probability 1 minus Q. Okay, so these black numbers give us the payoffs for the player 2. Okay, now here we can see that since there is randomness in the picking up the strategies, okay, the payoffs are no more certain. We don't have the certain payoffs because there is randomness in picking up the strategies. Okay, so whenever we have the randomness, we mean to find the expected payoff. We cannot find the payoff, certain payoff, because there is randomness in the choice of strategies. Okay, so how do we write the expected payoff? So expected payoff is given by what, it is simply given by, that is expectation of random variable. So what is our random variable here? To play PR 1 minus, to play up or down, here also up or down. Okay, so we will have here the expected payoff, not the certain payoff. That means for player 1, so for player 1, what will be the expected payoff? Expected payoff for player 1 is equal to, okay, if he plays, the expected payoff is when player 1 plays up, okay, and player 2 plays up, he will get 50. Okay, so his payoff will be 50 into P into Q, the probability associated with that P into Q. Okay, how do we get the expectation? Let me be clear with this. So whenever we want to find the expected, let us say we have the random variables, let us say we have x1, x2, and so on to xn. Okay, and these random variables are having the certain probability. Let us say x1 is being played with probability p1, x2 is being played with probability p2, and similarly xn is being played with probability pn. Okay, then what is meant by expected payoff or expected function will be that we take I is equal to 1 to n. Okay, we multiply uh, each random variable with the probability associated with it. That means we have x1 into p1, okay, plus x2 into p2, okay, similarly xn into pn. That gives us the expected payoff. Similarly, we have here, since we have two strategies, up and down, so expected payoff for player 1 will be 50 into p into q, that is the probability associated with this random variable, random variable of u, which is 50. So we have 50 into p into q. Okay, so let me rub this out, plus then we have 80 into p into 1 minus q. Okay, p into 1 minus q, plus we are actually taking the expected payoffs here. Okay, so we have then 90. So expected payoff will be sum of these red numbers with probability associated with them. So 90 into 1 minus p into q. So we have 90 into 1 minus p into q. Okay, plus we have 20. Okay, 20 into 1 minus p into 1 minus q. So we have 1 minus p into 1 minus q. This will be the expected payoff for player 1. Okay, so let's try to solve this out. So we have e1 will be equal to, so we have 50 p q plus 80 p minus 80 p q plus 90 q minus 90 pq, plus we have 20. Okay, if we solve this out, what will it come out to be? This will 1 minus p 1 minus q, it will come out to be 1 minus q minus p minus pq. Okay, sorry, plus minus into minus is plus. So in place of this, so we have to multiply 20 with this thing. Okay, so this will come out to be This is 20 into this very thing. I am solving it here. So this is 20 minus 20q minus 20p plus 20pq. So in place of this, I can write 20 minus 20q 20q minus 20p plus 20pq. Okay. So I'm just calculating the expected payoff that the player 1 will get. Okay, let's try to solve this out. Can I do the calculation correctly here? Let me see. So we have 50 PQ, 80 PQ, 90 PQ, and 20 PQ. Okay, so what will it come out to be? So 50 minus 80. So we have 50 minus 80 minus 90 plus 20. Okay, because these are like terms, we can add or subtract them. Now what will it come out to be? 50 minus 80. 50 minus 80 comes out to be 30. So we have minus 30 plus 20 minus 90. You go, I say minus 10 minus 90. So this comes out to be minus 100. So we have, I can write it like this. We have minus 100 PQ. Okay. After that, we will see the like terms, like we have P here, we have this P here. Okay. So we have 80 minus 20, it will come out to be 60. Okay. So we have 60P. Okay. Then we will see uh, Q. Okay. Let us see what if we have Q. We have 90 minus 20. 90 minus 20 will come out to be 70. Okay. So we have plus 70q, and obviously we have this plus 20 as constant. Okay, so let's try to solve this. So we will get here, we can write it like this. We have 20 20. After that we will write 70q, then we have 60p minus 100pq. Okay, or I can write it like this: 20 plus 70q plus, if we take 10 common here, okay, we are left with 6 minus 10q. Okay, so this is the expected payoff for player 1. Okay, now if it is the expected payoff for player 1, now what will player 1 will choose? Player 1 will choose P. That means player 1, let me write it here, I forgot to write here P. So we have 60, 10p here. Okay, we have 10p here. That means player 1 will choose p in such a manner that E1 is maximized. Okay, so he will choose this probability p such that the total expected payoff is maximized. Okay, if we look at this expression of E1, that's expected payoff for player 1 can do nothing about the first two terms. Why? Because simply his choice of variable, that is, since player 1 is playing p and 1 minus p, since in the first two terms there is no choice variable of player 1 because we have q here, so he cannot do anything with the first two terms. So obviously he is left with this very term, this last two terms. He is able to manipulate these terms. Okay, last two terms. Okay, because the choice variable is there, because he can control this p variable. Okay, so he is not able to do anything with the first two terms. Okay, now how can we maximize the expected payoff? Okay, let's try to see. If this 6 minus q let me write it here. Okay, he can affect this very part only. Why? Because P is involved in this term, because we are taking the expected payoff for player 1, and we have P here. Okay, he cannot control the first two terms, he can control this P. Okay, now what will happen if this 6 minus 10q is greater than 0? If this thing comes out to be greater than 0, okay, then obviously player 1 will choose P with probability 1, because if it is positive, this thing is positive, and we have here probability 1, this whole will become positive. That means this expected payoff will increase. Okay, if this term, that if 6 minus 10q is less than 0, okay, if it is less than 0, what will happen? The expected payoff will decrease, because if this term becomes negative, so expected payoff will decrease. So player 1 will choose P with probability 0. Okay, and if 6 minus 10q is equal to 0, okay, if it is equal to 0, then player 1 will choose P. He will be indifferent, rather he will be indifferent in his choice of P, so it will lie between 0 and 1. Okay, and let's try to write it, further solve this. Okay, so we can write it like this. If 6 minus 10q, if we solve this here, so this means 6 is greater than 10q, which means 10q is less than 6, which means q is less than 6 upon 10. Okay, so I can write, if uh, q is less than 6 by 10, player 1 will choose P with certainty. Okay, he will choose P with probability 1. Okay, similarly, solving for the second, if we have 6 minus 10 is less than 0, we can write it like this: 6 is less than, transposing, this will become 10q, or 10q is greater than 6, or q is greater than 6 upon 10. Okay, so as long as q is greater than 6 upon 10, player 1 will choose P with 0 probability. That is, means he will not choose, he will play with 0 probability. Okay, similarly, if 6 minus P, 6 minus P is 6 minus 10q, 6 minus 10q is equal to 0. That means 10q is equal to 6, or q is equal to 6 upon 10. Whenever we have q is equal to 6 upon 10, okay, player 1 will be indifferent of his choice of playing P. Okay, so it will lie between 0 and 1. So let us create the best response correspondence for player 1. Okay, so how do we form this? Let me write it here. Let us say we have q, rather let us say we have P variable here and Q variable here. Okay, now let's say this is here 1 1. Okay, this is probability 1 and this is Q as probability 1. Okay, so we have seen here, whenever Q is less than 6 upon 10, okay, whenever Q is less than 6 by 10. Okay, so let us say this is 6 by 10, 6 by 10. Okay, whenever Q is less than 6 by 10, player 1 will choose, uh, strategy P with probability 1. Okay, so player 1 will choose this very part. Okay, whenever we have Q less than 6 upon 10. Okay, and when Q is greater than 6 by 10, whenever we have Q greater than 10, sorry, I have not shown it correctly here. So let me rub this first. So let's try it again. So we have P, we have Q here, we have 1, 1. Okay, we say whenever Q is less than 6 by 10. Okay, let us say this is 6 upon 10. Whenever Q is less than 6 by 10. Okay, player 1 will choose to play P with probability 1. Then player 1 will choose to play like this. Okay, when Q is greater than 6 upon 10. Okay, when Q is greater than 6 upon 10, player 1 will choose uh, P is equal to 0. Okay, so we have P is equal to 0 at that time. Okay, when Q is equal to 6 upon 10, he is indifferent. That means his best response curve will be this very thing. Okay, so let me repeat. Whenever we have Q is less than 10, 6 upon 10, Q is less than 6 upon 10, player 1 will choose P with certain probability of 1. Whenever Q is greater than 6 upon 10, player 1 will choose P with 0 probability. That means he will be here. Okay, and whenever we have Q is equal to 6 upon 10, then he is indifferent. Okay, between choosing rather playing P. Okay, so we have this very thing. This is called the best response correspondence of player 1. Okay, now we need to find the expected payoff for player 2. Okay, same steps are involved. So let me rub this out and I will try to um, explain it more suitably. Okay, so as I have told you what is meant by expected payoff, we don't have here certain payoffs because there is a randomness in the strategies that the player plays. Okay, so let's say for player 2 we denote E2 as the expected payoff for player 2. Okay, now what will be the expected payoff for player 2? It is simply we see the payoff and to this we multiply the corresponding probability. So player 2 will get 50. Okay, let me write here. Player 2 will get this black 50 with probability P and Q. Okay, so we have 50 P into Q plus he will get 20 with probability P and 1 minus Q. That means when player P plays up with probability P and player 2 plays down with probability 1 minus Q. So we have 20 P into 1 minus Q. Okay, then this 10 is the payoff for player 2. So it is equal to 10 multiply it with probability 1 minus P into Q. Okay, then we have this 80 as expected payoff for player 1 and it is being played with 1 minus P and 1 minus Q probability, that is 1 minus P and 1 minus Q probability. Okay, now what we need to see, we need to find the expected payoff. Let us first solve this out. Okay, so we have here a 50. Let me write here E2 is equal to 50 PQ plus 20 P. uh, we have 20 P 20 P minus 20 PQ. Then we have 10 into 1 into Q, that is 10Q, minus we have 10 into P into Q, so 10 PQ. Then we have this. Let's first solve this. We have 1 minus P 1 minus Q. So this is 1 minus Q minus P plus PQ. Okay, and to this we have to multiply 80. Okay, so this comes out to be 80 minus 80Q minus 80P plus 80PQ. Okay, so in place of this I will write this. We have 80 minus 80Q minus 80P plus 80 pq. Okay, so let me rub this out. Let's try to add upon the like terms. So we have 50 pq here, we have 50 pq, then we have minus 20 pq, then we have minus 10 pq and 80 pq. Okay, these are the pqs. I will not write here. So let's see what it comes out to be. This is 50 minus 20 is 30 minus 10. This comes out to be 310 plus sheet. This comes out to be 100. Okay, so we got this 100. Let me write it here. It is 100 pq. Now what are our p's? We have 20p, 20p, then we have minus 80p. So 20 minus 80 comes out to be minus 60p. Then we have q, so we have 10q, minus 80q comes out to be minus 70q, minus 70q. Okay, and we have the constant as 80. Now we can write it like this. We have 80 minus 60p minus 70. Let me write first this 100. Okay, then we have 100 pq minus 70 q, or we can write it like this: 80 minus 60 p plus taking 10 common, we and q common, we are left with 10. We have 10 p minus 7. Okay, now this is the expected payoff for player 2. And here also you can see in the first two terms, okay, player 2 cannot do anything with the first two terms because his choice of variable is not in the first two terms. His choice of variable is this time q. Okay, and this appears in the this very part. Okay, let me write in this part. His choice of variable appears in the first two. He cannot do anything with that. Okay, now what will player 2 will try to, he will try to maximize this expected payoff. How can he maximize this payoff? That means let us see, if this thing, let us say if 10 minus p, sorry, it is 10p minus 7. So if 10p minus 7, if this term is positive, okay, when this thing comes out to be positive, obviously payoff will get increased. Okay, then player second will play q with probability 1. Okay, because if this thing comes out to be positive, so we have 10 into this positive number, that means his utility will increase. Okay, similarly if 10p minus 7, if it comes out to be less than 0, okay, then obviously player 2 will choose q with probability 0. Okay, and if 10p minus 7 is equal to 0, so then in this case he will be indifferent with q. Okay, 0 and 1. Now let's solve it further. So if 10p minus 7, we have 10p minus 7. Let me write it here. So we can write 10p, transposing this, it is 7, or when p is greater than 7 upon 10. Okay, I will write here, if p is greater than 7 upon 10, okay, then player 2 will choose q with probability 1. Okay, similarly if we solve this, it will come out to be, if p is less than 7 upon 10, okay, then q will choose player 2 will choose q with probability 0. And if p is equal to 7 upon 10, Okay, I have not shown the calculation. You can do it easily as I have shown it here. So player 2 will be indifferent with the choice of playing Q. Okay, it will lie between 0 and 1. Okay, now let's draw the best response correspondence for player 2. Okay, similarly, let's try to make it here for player 2. Let's draw it here, or let me draw it here if I have this space. We have P, we have Q here. Okay, now we have P is 7 upon 10. Let us say this is here 7 upon 10. Okay, let us say this is here 1, and here we have 1 as probability. Okay, now what is here? We are being says whenever P is greater than 7 upon 10. Whenever P is greater than 7 upon 10, player 2 is playing Q with probability 1. Okay, that means player 2 will choose to play in this space because Q is equal to 1 whenever we have P greater than 7 upon 10. Okay, whenever we have P less than 7 upon 10, whenever we have P less than 7 upon 10, okay, player Q chooses player 2 chooses Q with probability 0. Okay, so in this case we mean he will choose in this region, that is Q is 0 here. Okay, and whenever we have P is equal to 7 upon 10, he is indifferent between Q. Okay, so obviously we will have this very thing as the reaction function. So it is here actually like this. Let me rub this out. We have 7 upon 10 here. It will come out like this. Okay, I hope I am making the graphs correctly. Okay, this will be the best response correspondence for player 2. Okay, this is best response correspondence for player 1. Okay, let me repeat it again. So whenever P is greater than 7 upon 10, player 2 will choose Q with certain probability, that is he will choose play in this region because Q is here 1. Okay, this is the probability space actually. Okay, whenever P is less than 7 upon 10, he will not choose Q, so he will be in this region. Okay, because Q is here 0, and whenever P is equal to 7 upon 10, player 2 will choose, he will be indifferent. Okay, so this very thing, this region denotes when P is equal to 7 upon 10. Okay, now what we need to see, if we plot the two best response correspondence together in a single diagram. Okay, let's see if we can draw them in a single diagram. So making it a single diagram, we have P, we have Q here. Okay, so black will be, this black will denote the best response correspondence for player 1, and it will come out to be like this. Let us say this is for the player 1 best response correspondence. Okay, here we have this 1, here we have 1. Okay, and for player 2 we have this very thing. Okay, so let me draw it here. Obviously it is not equal to 1 here. We have 1, this is here 7 upon 10, sorry, we have this 6 upon 10 here, and this is 1 here. Okay, then for player 2 we have 7 upon 10. So let us say this is here 7 upon 10. Okay, so player 2 will be choosing so rather playing in this region. Let us Okay, I hope I am making myself clear here. Okay, so if we plot the two best response curves correspondence together in a single diagram that we have done here, they will intersect at a point. Let us say this is point R. Okay, and what are the coordinates of R? It is simply when P is equal to 7 upon 10, 7 upon 10, and 6 upon 10. Okay, this is the coordinate of this point. Okay, and the intersection of best response correspondence gives us the mixed strategy Nash equilibrium of the game. Okay, so in equilibrium, what will happen? Player 1 will mix, that I will write here. Player 1 will mix his strategy, his strategy, his strategy with up, playing up. Okay, with probability, what we got, with 7 upon 10, and playing down with probability. If this is 7 upon 10, if p is equal to 7 upon 10, then 1 minus p means 1 minus 7 upon 10, that means 3 upon 10. Okay, he will play down with probability 3 upon 10. And similarly, player 2 player 2 will mix his strategy with playing up with probability 6 upon 10, 6 upon 10, and down with uh, what is 1 minus q, 1 minus 6 upon 10. This comes out to be 4 up, sorry, yes, 4 upon 10. Okay, 4 upon 10. Okay, so mixed strategy Nash equilibrium for this will be that player 1 will choose 7 upon 10. Okay, and down 3 upon 10. So I will not write it here. Okay, so these are the mixed strategies for player 1 and player 2, and this intersection of best response curve gives us the mixed strategy Nash equilibrium for the two players. Okay, I hope I make myself clear in this video. So if you have any questions regarding this question, okay, I will try to answer them if I can. So I have tried to make it very simple for you people. Okay, thank you.